Afternoon. We're going to have to be swift. What you're looking at here is an interesting slide, and over the video and recordings and data in whatever way we could watch the water behave in a different state. This is a disconnect of a 2x4 from the plasma flame, and every time in a 10 millisecond frame you can find one of these. It's kind of a different, the UV normally goes up and down on the screen, and this is a lot more blue. You'll see later it's usually more purple. We'll just get right into it. We're going to talk about principles that are exemplified in water. It's important to build a foundation to understand on. I think fractals are essential, as kind of like learning a number system or the alphabet as far as patterns go. So don't get too deep into anything that's presented or goes on. It's a what-if situation, and be entertained by what's happening with the water. It's the best way to view it. And these patterns that go on, look for the patterns. Don't try and overthink them. There's very simple patterns that are going on over and over. Again, this is a more advanced form of fractal from Kanner's version of just chopping the middle third out of the line, and you kind of see a two-dimensional version. And the common thing here is the surface area is going up. So if surface area was charge dependent or vice versa, as in the ability to store charge, in the same circle, a more complex shape can hold more charge, more energy. Don't need to get into positive and negative charge or not. It's just, it can hold more of it, whatever you want to call it. And there you have three-dimensional, where if we zoom in on any single spot, in the micro, we see the same as the whole. So Reif said, you know, when we looked inside the cell inside of the cell, we found another cell, and when we looked further again, we found another cell. That's fractal. You complicate it a little bit more, make a little twist on the equation, feed it to a computer, and it spits out artwork, beautiful artwork. Here's Mendelbrot. His big donation was realizing that the coastline is infinite. Therefore, a particle is infinite. A particle could complex its shape theoretically infinitely, which means it could hold an infinite amount of charge. What if? This is Babbitt's particle, late 1800s, and if you're getting the pattern now, when you look in one of these small circles, if you could zoom in on it, what would you see? And this was postulated back then to go on and on. Tesla, J.J. Thomson had a similar model, and Tesla referred to J.J. Thomson a lot, and practically Tesla made it a lot further than most other people. So what he was using allowed him to achieve things that couldn't have been done before. So connect the dots together. What if everything's just a tight bundle of light and it's changing its frequency to change its behavior? And that's how we define it. Subtle energies, orgone energies, we're going to get into that one. I put up, this is my take, is same as Wilhelm Reich's, is that till people learn about it and can be responsible with it, and especially with water, respect it, this technology is not going to come screaming out. This stuff's been around for a long, long time. I didn't know it at the time when I started researching it, and it kept an open mind because I didn't look at what other people did or have their names or their preconceptions. So I realized if you don't overcomplicate it, we're taking water, we're putting any energy into it. I did some tests, it's still a water vapor, here we go, and then the publishings are finding these types of things. So in the past, this had other names, HHO, Rhodes Gas Hydroxy, all the way back in the 60s with patents on it. And I'm wondering, you know, this stuff's amazing. Why aren't we hearing more about it? So now we are. Torsion physics and subquantum kinetics, Paul LaViolette, he'll be speaking later today. They deal with more of how this stuff may actually move around, looking at the motion of it. The motion is more important than defining it and freezing it and saying what it's in. It's all in transition all the time. So why try and freeze it and name it? Here we have a left turn causing a left spin and a right turn causing a right spin, and where the two overlap is where a counter vortex occurs, and this is how nature does it. Weiss emulates that point of overlap, where Victor Schauberger calls it an energy cannon. Simple principles here. Like seek likes. People are getting familiar with that. There's both sides of the coin, always. And division seeks to cancel itself. So division does come together, but when it does, it cancels itself. The magnet's the great example. If you try and put like poles together, it causes spin, the opposite poles come together, and then they disappear and move farther apart. So at the end of a natural reaction, the north and the south pole are moved farther apart. So opposites are moved farther apart, the magnet seats the magnet. Again, same thing going on, same pattern. Here we polarize water by splitting it up. We pump in one common line, split it in two directions. Water wants to come back together when you split it apart. There's more energy in the recombination of water than there is in the separation of water, and that's why this technology is viable as energy source and can be used in these directions. But same thing, going on. I built one of these before. They're finicky to get working, but they do work. You can make 1,500, 2,000 volts, no problem. And Schauberger's son, I believed, used this to measure the quality of water. He said higher quality water would spark 9, 10 times where tap water wouldn't spark once. This is interesting on Tesla. He's talking about vibrating plates, and he goes on to say that the assumption is that these plates have to be dependent on each other, and then he goes on to say, but there's really no probability for that whatsoever. So these charges could be separate and independent of each other. And he talks about an electrostatic force. So you got to remember, back in his day, he didn't have all the terminology of atoms and these definitions, so they were just defining energy movement. He kind of makes fun of the language because it's not static at all, he's saying. I believe he understood that it was actually traveling faster than the speed of light, and all you had to do was tap that. Push or pull, another simple concept. Pull on a string, it gets in line, and it follows the lead. Push on a string, it kind of causes a mess. You see a Tesla turbine here, and if you're going to push, push from the outer edge, kind of common sense. There's huge problems with plus and minus charge and negative ions and all this language. First, you have to determine whether it's saturated or supersaturated. The problem, generally, nature needs plus and minus to work together. So the problem comes from supersaturation. Like this, it doesn't matter if it's all men in here or all women here or men and women in here, plus or minus charge. It's a mess. That place isn't clearing out anytime soon. This is my favorite topic to study vibration and how things go. So when we get to the basic cell design, which I won't have to spend much time on, I just look at a transmitter plate as a guitar string. And so now you build on that and you start making harmonies. So if you play a harmony or let a water cell manufacture a harmony, it performs better, it takes less power, and it makes a higher quality plasma gas. So it's a little bit more than theory when it actually results in positive efficiencies. So some of the concepts I learned in music from application of playing it and playing in a band, I was like, hey, the bass player, you can never hear when he's out of tune, but if the lead guitar is way out of tune, you hear that right now. So, maybe it's easier to build with lower frequencies. Everybody's trying to go higher and faster, and I went to the bass notes and found a lot of efficiency there. Interesting story behind the Huntley book with Theo, who will be speaking later. I can't get too much into it. You see, Schauberger says you must think one octave higher. They say light shifts in octaves. Again, what if? And reflection harmonics. Huntley talks about this a little bit in his book. And octaves are just doubling, 1, 2, 4, 8, 200, 400, whatever number you want, it's just doubling. That's how it works vibrationally. And it's one of the first places to start is playing multiple octaves to get a more harmonious effect. Here you see VBM or vortex-based mathematics. 1, 2, 4, 8 is a doubling sequence. That indicates a rise up to an octave, and then the 5, 7 back to the 1 is a fall. They split the 3, 6, 9 out. A lot of people notice that 3, 6, 9 shows up if you sum numbers, and more often than anything, there's kind of a magical quality to it. Implosion, explosion technology or expansion technology, heat technology, it's bad. And then so now we have to go to implosion, and it has its own consequences. Here you're going to see when you implode too fast, and you might not even see this implosion occur, but you can measure you can't see anything come out. but you can measure the radiation that results from it. So a lot of times the radiation comes out, it's like, what happened? Well, there might have been an implosion. Same is true for U-235 in fission. You don't shoot a bullet at an atom and split it in half. It actually absorbs, so it goes through integration and it vibrates and shakes apart. They actually measure this fission time. It's pretty slow compared to the rest of the reactions going on. So it's actually imploding first and then breaking apart with energy, in my opinion. So there's no spin in this equation. Spin's a buffer for a reaction. So if we were to spin this thing before we popped it, you might see a different result. That's the radiation. Why couldn't an atom do that too? Here you see a bubble shrinking. Again, the bubble doesn't have the toroid yet, but maybe the toroidal energy field, electrostatic field that's moving is there. And then you get a resonance zone where this happens. And these things actually will drill holes in stainless steel props. They call it cavitation, but it's not cavitation by definition. The previous slide, what you saw would be considered cavitation. This is a controlled standing wave that's a spin system. They use it with ultrasound to clean things because that drill or brush is sitting there cleaning up stuff. Victor Schauberger's version of what he thought was going on in water theoretically: negatively charged hydrogen in the center, in the microvortices that are strong and stable still. I think he's got 12 of them drawn on here. The oxygen spinning in the counter direction, and the whole oxygen band is going in the same direction. It comes out like a planetary gear, possibly electrically coupled. You see the side view of it there. The water guides itself, and it stratifies. So you can't see it in the resolution here, but more or less there's a temperature gradient that's really, really small. As long as it's cooling down, it's pulling in and increasing energy in the system. It's the opposite of our other science, right? They say it's cooling down, so it's losing energy. You know, not really. Orgone accumulator layers, or you can get effects out of dielectrics too. So organics, carbon basically comes down to a dielectric material also. So we could substitute and begin to see similar principles, but alternating layers. Again, look for the patterns. So here I thought, well, what if there was any proof that water was organic for real? Schauberger used the language carbones and carbogenes, and his idea was is water forms the energy of this carbon, which then resonates with life here on Earth, and that's how it all works. So I went into an old library and pulled a book from the 1930s, late 1930s. It's the London Research Institute Cancer Studies. And they wanted to see what happened with water first. So the whole book was full of what happened with water before they tested people. And they all went off in anomaly directions. There was stuff happening everywhere with the radiation that shouldn't have been happening. This is what was happening to the systems I was working on. And I was like, there's only one explanation for this. I don't see anybody talking about it. But if the spin, increased, then the energy is being stored that way. You wouldn't see it as temperature. Actually, it's like an ice skate or tucking. If you had a lot of them, you could fit more of them in a rink. But it's dangerous, right? Because you got more spinning faster. So if somebody flicks that thing, the mouse traps go off. And that's precisely what would happen. I did tests. I'm going to cool this down. And if I cool this down and all of a sudden it heats up, I know the model's going in the right direction. So I cooled something down really rapidly, and the temperature went screaming up on it, and the energy was unlocked from the water. Here they go on to say, the key experiment, they did this with pure hydrogen in the form of radiation. 6 hydrogen atoms were formed per ion pair, so when you draw that out, why couldn't one group behave as relatively negative and the other positive, and now you have a simulated carbon? There's a little bit of evidence for it by credible sources. Again, the pattern, alternating layers of dielectrics and conductors. Go ahead, Jeremy, play this one, please.
Unlike conventional generators, the electrons will be moving at extremely high velocity. Conventional currents are slow currents, and they build up heat. The more current you draw, the more heat you get. This system is the opposite. The more current you draw, the colder it gets. For this reason. At the quantum level, the electrons are riding the magnetic field, not hitting the lattice of the atom. so they accelerate to higher and higher speeds.
Thank you. So take what works for you. Anybody's single theory is not going to work for you. Grab the pieces that work for you and are simple and start to help explain more advanced technologies that will be coming in the future. So resonant water plasma is what I named it. I named it that for a specific reason because it's fairly cool to the touch. It doesn't radiate heat, but when you aim it at things, it seems to automatically adjust its temperature, and it won't overheat it, and it won't overheat it unless you start to really force the equation. You can, but on its own, it's very subtle and very gentle. This is a basic design of a series. So these are sympathetic. So basically all these plates vibrate with each other in a certain phase relationship, like all the same note. Interesting thing is these things, when run properly on the next level of efficiency, will create a higher frequency out of the two same frequencies by phase adjustment between two same notes. So it's not a binaural beat. A beat implies a lower frequency going on by mismatch frequencies. It changes the derivative or rate of rise in order to create a cross effect, so you get double the frequency out of it. And you also get a third, a fourth, or a fifth musically. It manufactures frequencies. 3 additional phases. Gerald Pollack kind of started the 4th phase thing. I would argue that and say these are just phase allotropes, and now we have pretty good evidence to support that from existential research all over the place. Again, these bubbles may not be toroidal, but they probably have a toroidal energy field around them. And later on, you'll see in videos, we'll start to unlock that with the plasma. If it was in there, then we should be able to induce it where we see a vortex form or a toroidal field of such. So ice and stable water clusters are the solid. The stable water clusters arrive out of a situation of homeopathy where you dilute the water so much that whatever's in it, let's say it was sodium chloride, moves far enough apart, the fields expand trying to get back to each other. And at a point, they basically give up and collapse. When they collapse, it's possible that if they collapse at the right rate, they make a vortex and they freeze into those shapes, or they could break down too fast and shatter into crystals. And structured water would be the liquid form, and steam and water plasma. So when water plasma comes back on the spectral, we try and tear the water apart to analyze it, but it still stays mostly together, and it comes out largely water vapor. So it's a highly energized water vapor with both poles. I wouldn't say it's plus or minus because it's unwinding itself. So when you unwind a charge plus and minus, they go to a common point that's in a lower or higher state depending on what's going on. It's really not plus and minus dependent. From water vapor back to water, there was probably supposed to be something there. Oh, there we go. My hand is actually in it here, and that's why it's yellow. Normally it's blue. It was hard to, I looked at the original video and I kept my hand there for 30 or 40 seconds, and occasionally my hand would bump into the flame. It will burn you if you stick your hand in it, but it doesn't radiate any heat is the point. You can condense this, and it has a shifted pH, and you short circuit, it will boil. A lot of the Brown's gas people say it won't boil itself. It absolutely will. I've done it 50 times. And it's interesting things occur at that phase change level. So a pH of 2.3, and then you can get that pH to flip over. And we've had samples stable at 12 plus pH for it's probably 10 years now. We'll have to check them again. And here we use the high pH compared to Royal Purple. It had a pH of 12.3 also with a bunch of chemical in it. And we did isolations with free and distilled water. And there's the pure water 12 pH, a little bit of stuff in it as far as ppms go. Go ahead and play this one, Jeremy. It took a lot of time for these crystals to grow, and it looks like as the pH decreases over time, these crystals form in the water. They're very pretty, but that was a pure sample when it went into incubation, and I let it sit for 3 years and pulled it back out, and I was like, what the heck's all this? But there's evidence that this happens. The double helix pattern, you see it everywhere, especially when vacuum is present. So you get a pull on it, it seems to organize the charge around, a cooling function. This is an electrical discharge. You can see the two strikes on the plate showing that there's actually two strands, so it's not an optical illusion. It's a physical result also. Stable water crystals, you see the same thing. Certain methods of it. Theo will have some better pictures on this later, how well formed they can be. This is under a microscope, and this is water. This is pure water at room temperature forming a solid. And this is crystal shard versions attacking a piece of bacteria, it kind of looks like. It's probably electrically related to it. So again, the perfect geometry by situation and the right levels and the right pressures will create a double braid. Typically only single will occur. Just the right conditions, this double braid will occur. This one's really interesting. This is a plasma ball next to the sun the size of Jupiter, and it has a double braid. And it looks like it's interacting with the sun and goes anti-gravity with the sun. And this standing wave, this plasma, a lot of people thought it was a UFO or whatever. It's most likely a plasma ball. Go ahead and play this, Jeremy. Watch the 3 into 1 with the vortex. This is typical of starting up a vortex softly. You see 3 vortexes, they get together and make one. Go ahead. Watch it take off. This was humble beginnings of the lab. I ran a lot of experiments with voltage and frequencies, and so we're building different types of vibratory cells now, kind of an evolution of them, tested them. Shops kept getting bigger, cells kept getting bigger, run times got longer, efficiencies got better. Here's nature showing us what's going on. There's should be a video in here, Jeremy.
Sonic weapon. First, its claw is cocked like a pistol, then fired. The effect is literally stunning. As the claw snaps shut, it fires a blast of bubbles. Incredibly, as the bubbles collapse, they momentarily reach the temperature of the sun.
It's a little shrimp that snaps its claw, and it makes an implosion bubble that they theorize goes to 10,000 degrees Fahrenheit. Some form of awareness of what it's working with, through hydrogen resonance probably, and other fields, ranges from 250 in air to 10,000 degrees in contact with a pure tungsten witness. You can put uncommon materials together like steel and brick. Laser will form just with air inside of it, contained inside of it. And this is a really cool one you're going to see in a video. We're going to start to move fast to get through this now. The torsion in the gas. The gas is actually parked above water in a container, and somehow, this is the stored spin energy, somehow the gas grips the water and turns it at quite a rate. Now the gas is still up there theoretically. It's all closed off. We're not pumping anything into it. And it somehow grabs the water and starts to rotate it. So when we get to this first slide of an implosion thing, I'm going to slow it down so we can see what's going on. But in the first one, there's glitter in the water, and you can see it rotate. So this charged field must be spinning very fast for a gas to couple water and make it turn. And you'll see it's not just stray motion. So here's the experiment. There's a implosion chamber submerged in the water. And the plasma gas comes from the generator and just set at the pressure just to displace the water out of this container. And then a Tesla coil is used. We are processing water this way. We use a Tesla coil so it could keep arcing on the gas. And we just fed it continuously, so it just kept drawing up the water and treating it. It definitely makes changes to the water in a single reaction. And you'll be watching. See the glitter turning? Now, it sounds like gunfire, and you'd think that was an explosion, but no water splashes. We'll slow it down so you can see what's happening. Let me see here. See the UV from the floor, that's what's really going on. Now it's being vacuumed back up. And there's a vortex that forms at the end of it, so we'll get to still shots to see that. Here's a still shot. At the bottom you can see, this is underneath the cart. And the first thing that happens is the Earth lights up with UV, then UV comes out of the chamber. So Tesla talked about this. We didn't expect to see it. It was very interesting. So that's the first thing that happens, is a radiation that has no direct interaction with the water physically. Then we see full ionization. This only happened once. The water changes where the conductivity changes. This doesn't happen again. And here's the water going back, being pulled back up in. These are about 5 to 10 millisecond spans, so pretty quick, not ultra quick. Here's going into the red. So if you look, it's doing a frequency sweep. And there's another thing going on here, is a sound develops out of this. So the only sound sound is a frequency too. It's sweeping through all the frequencies. We don't know how high to how low, but this ends up in an audible sound when it's controlled in a vortex. I'm going to end up going over just a hair, but it's all right. And this is the last phase, and this is a vortex. And you can hear this thing audibly as it goes up the reaction tube. It's more complicated than what I explained how to control this reaction, but you could control the speed of the vortex, and you hear it like a gear set winding up and down. And you'll hear that with the water plasma too. Those little donuts on top of the brick are where you drill holes and it makes a glass tunnel through brick. And here's how fast it reacts with fire brick. It's instantaneously. So the higher the melting point, the faster the reaction occurs, which is not typical. Here's tungsten evaporating at 10,000 Fahrenheit. And you can hold this rod with bare hands. The second you take that rod out of this connection, the heat comes screaming up that rod. It's hot. But if you keep it in there, it's not that hot. It takes a long time for the heat to transfer through the tungsten rod. Hybridization, here's a propane flame about the size of brick lighter. Here's 200 watts of plasma mixed together in a special way with it. It's quite an effect. Here's cutting through 8 inches of steel for a steel mill trial in the Midwest. It had advantageous properties for the metallurgist. You can see the blue finish. This can happen with regular cutting, but it's hard to get to happen, and it takes certain grade steels. This is very mild steel where the ceramics tend to get pushed to the center, which is a problem because the metal gets weak in the center. This part goes on to get further processed. You see how easy it is to clean the slag up, and that's an anti-corrosive bluing finish on there. So there's all sorts of different applications it can be used for. The East uses it. I think incineration is the best one. You can throw a bunch of stuff in a crucible and burn it down with no smoke. And I'll leave you with the video. Listen for the wind-up sound of the plasma and the vortex formation, and the heat. The heat is being pulled back towards the reaction, not radiated out. Thank you very much. Enjoy.